we call an area problem. So let's again read it together. A farmer wants to make a rectangular corral alongside of a large barn and has enough material for 60 meters of fencing. So we only have 60 meters. Only 3 sides must be fenced since the barn wall will form the 4th side. What width of a rectangle should the farmer use so that the maximum area is enclosed? So if that's my barn wall, so that's the barn, and that's where the animals are, I only need to fence on 3 sides. So I have 1, 2, 3 sides. Now let's look at our rectangular shape over here. How many widths do I have fencing for and how many lengths? Well, if I start over here, I have 1 width, 1 length, and 1 more width before I reach the wall of that barn again. So we have 2 widths and 1 length and 60 meters of fencing. Now, if we think of what the 60 meters represents, the 60 meters is the outside perimeter of that enclosure. So the perimeter of the enclosure is 2 widths plus a length. Now let's label our width with X. And let's see if we can represent one of the dimensions using the other one. So 60 equals 2x plus the length. And I'm going to try to isolate the length and express it using the width. So length equals 60 minus 2x. So I have the length represented using x, and I have the width representing using x. Now let's move on to our problem. The question is, what width of a rectangle should the farmer use so that a maximum area is enclosed? So as soon as I hear the words maximum and area, I have to think of what I know. When do we hear the words maximum and we think about quadratic relationship? Immediately we have to say maximum is vertex form. Now, which of those letters gives me the maximum value of a function? Well, it is Q. I'm just writing what I know. Now let's go back. Maximum area. Well, how do we find the area of a rectangle? It is length times width. So the area of a rectangle, in my case, is 60 minus 2x times x. And we're trying to find what x value we need to have in order for this area to have a maximum value. Well, maximum value, we said, means vertex. Vertex means rearranging my function in vertex form or finding the vertex form from right here. Again, we have 2 options. Well, option 1 is factored form, and option 2 is vertex form. Well, in factored form, we know that if we average the 2 roots, we will find the axis of symmetry of that parabola. So what are the 2 roots in my equation? Well, the area equals 60 minus 2x, everything times x. Now, the area looks already like it is in factored form. Let's figure out what the 2 roots of this, or what the 2 x-intercepts of this function are. Well, one of them is going to be x equals 0. And for the other one, you have to set this bracket to 0 and extract the x, for which x equals 30. Now, between 0 and 30, that maximum point happens, that vertex happens. So what would be the the x value of the vertex or the axis of symmetry, well, we learn that it is halfway between the two x-intercepts, or p equals 15. Now, this p, or x equals p, which equals 15, is the dimension of the width that maximizes the area. So I've already found the dimension of the width that maximizes the area. Now let's find the maximum area. I'm going to substitute 15 back in the equation. So I have 60 minus 2 times 15 is 30 times 15. 60 minus 30 is 30 times 15 is 450 meters. So the best width, or the width that will maximize the area of that enclosure, is 50 meters, and the maximum area will be 450 meters. Now, option 2 is rearranging your relationship in vertex form. So in option 2, I am going to expand and simplify my expression, so it becomes negative 2x squared plus 60x. And I am going to complete the square. First, I will factor negative 2 out, and I'm left with x squared minus 30x. Now, inside the bracket, I have to add and subtract half of 30 squared, which is plus 15 squared minus 15 squared, equals negative 2 x minus 15 squared minus 225. And now we're left with taking away the square bracket, and the area would be negative 2 x minus 15 squared plus 450. Now, if I know that the maximum value of the area is given by the Q, then the maximum area will be 450, and it happens when the x, or the width of that enclosure, is 15 meters.